Hello students. Today our topic is units and measurement. As you very well know, physics is a quantitative science. To describe any physical phenomenon precisely or accurately, measurement of physical quantities is required. Since the laws of physics are described in terms of these physical quantities. Measurement of physical quantities means their comparison with certain references. In fact, we measure a physical quantity by comparing with certain basic, arbitrarily chosen, internationally accepted standard reference called unit. So, any physical quantity Q is equal to n times the unit U. We know that the number of measurable physical quantities is very large, but we need only a limited number of units to express all these physical quantities as they are interrelated with each other. Later we will see in the section mechanics the units of mass, length and time only can express units of all other physical quantities. You already have the concept of mass, length and time. As you know, mass of a body is the quantity of matter in the body and it can never be zero. Also, mass of a body is not affected by presence of other bodies or by the change of its location. Masses are of two types, inertial mass and gravitational mass. Inertial mass of a body is the measure of inertia of that body and gravitational mass of the body is the measure of gravitational pull of the earth on the body. The values of these two types of masses of a body are identical. I hope you have idea of inertia and also gravitational pull of the earth. Anyway, we will learn again about them in the coming lessons. Now, length. Length of an object is the distance of separation between any 2 points at the extreme ends of the object. And as you know, we have the idea of time, but it is difficult to define the time precisely. Einstein defined time is what a clock reads. Any phenomenon that repeats itself regularly can be measure of time. So we will see later the units of mass, length and time are sufficient to express all laws of mechanics. Now come to units. Units are the standard reference with which we compare the physical quantity. We have some fundamental or base units. The units for the fundamental quantities are called fundamental or base units. And in terms of these, all other physical quantities can be expressed. We have a large number of derived units. The units for derived physical quantities expressed as combination of the base units are called derived units. A complete set of fundamental as well as derived units is known as system of units. Presently, we use International System of Units, which is more commonly known as SI system. This system is developed and recommended by General Conference on Weights and Measurements in 1971 for international usage in scientific, technical, industrial and commercial work. SI system is the modern and developed version of metric system. In SI system, units are based on the powers of tens. It is of decimal nature. Hence, their conversion within the system is very convenient or easy. As you know, in SI system, there are 7 base or fundamental units and two supplementary units, one for plane angle and the other for solid angle. Some other systems of units are FPS system, which uses foot for length, pound for mass, and second for time. CGS system, which uses centimeter for length, gram for mass, and second for time. MKS system, which uses meter for length, kilogram for mass, and second for time. CGS and MKS systems are also of decimal nature. SI system is convenient and also internationally accepted, so we use the units of SI system everywhere. You can see the 7 fundamental units with 2 supplementary units of SI system on this screen. These are meter for length, kilogram for mass, second for time, Kelvin for temperature, ampere for electric current, mole for quantity of matter, candela for luminous intensity, radian for plane angle, and steradian for solid angle. You can see the symbols also used for these base units. There is a large number of derived units in SI system. Some of them are square meter for area, cubic meter for volume, meter per second for velocity, Newton or kg meter per second square for force, joule or kg meter square per second square for work and energy, volt for electric potential, ohm for resistance. You can make a list of these derived units. In coming lessons, we will learn about the various derived units along with derived physical quantities. Here you can see the definitions of two supplementary units, the radian and steradian. 1 radian is the angle subtended at the center of the circle by an arc equal in length to the radius of the circle. 1 steradian is the solid angle subtended at the center of a sphere by that surface area of the sphere which is equal in area to the square of the radius of the sphere. Besides units, dimensions of physical quantities are also important, which we will discuss in the next lesson. See you then.